So we're in Unit 2 and this is Worksheet 6. So I thought that I would go ahead and make a video of me working some of these problems so that you can use it before our test in case you don't get to come to our tutoring session to ask your questions. So you can feel free to fast forward through this as you like. Some of these are easier than others. So these are AP style questions, which will be very, very similar to the questions that are on the test, the style of question that is on the test. So just making the key for this. And I will tell you that I haven't looked at these problems in a little while, so I'm looking at them fresh just like you are. So as soon as I look at this first problem, it asks for the slope of the line tangent to the graph of g in terms of x if g of x is this. So we want the slope of the line tangent, which we know is the derivative. So if it's the slope of the line tangent to g, we know we are finding g prime. In this case, the variable is x, so we're finding g prime of x. So the first thing I notice is that g is a natural log. So I know that it's easiest to take the derivative of a natural log if we expand the natural log first. So that is going to be my first step. I'm going to expand that natural log. So I see a product. I see a product of two things here, and I see that each of the products has an exponent. So each of the exponents I can bring to the front of the log. So for natural log of x squared, that's going to be 2 natural log of x. For natural log of the square root of x cubed minus 1, that is going to be, it's plus because it's a product in here, and it's going to be 1/2 natural log of x cubed minus 1. So when you expand, it makes taking the derivative easier. Now we'll take the derivative. This is going to be 2 times the derivative of natural log x, which is 1 over x, plus 1/2 times the derivative of natural log of x cubed minus 1, which is, we have x cubed minus 1 in the bottom. You always put the argument in the denominator, and in the top you put the derivative of the argument. So this will be 3x squared up on top. So that's the derivative. That would be a safe stop. I'm going to look over here and see if it's over here, and I notice that they have everything is just a single fraction, so I know I need to combine these two fractions. So let's simplify a little bit. We have 2 over x plus 3x squared over 2 times x cubed minus 1. That's just simplifying each little fraction. And now the common denominator is going to be 2x times x cubed minus 1, just like that. So for the first fraction, this 2 over x, I would need to multiply top and bottom by the 2 times x cubed minus 1. So this will be the 2 that was already there, and I'm multiplying by another 2 times x cubed minus 1. Plus came from this plus. And now I have the 3x squared that was already there, and I'm multiplying by what I need to make the denominator, so I need this x. So I'm multiplying by another x. So we have 4x cubed minus 4 plus 3x cubed over 2x times x cubed minus 1, and this will be a 7x cubed minus 4 over 2x times x cubed minus 1, and I'm going to go look for that one, and is this it here? I can hardly see it. It's not focused very well. There we go. That's better. Yeah, that part B, answer choice B, would be it. Okay? So that takes care of number 1. Let's take a look at number 2. So for number 2, it's a little bit more straightforward the way they ask the question. They just say, here's f, find f prime. So I notice that, again, f is composed of, in part, this natural log function. So I'm going to first take f, and I'm going to expand it as much as I can. All right. So this x, I can't do anything with that, so I'm just going to leave it x. And it's going to be times, and now I'm expanding that natural log. So I'm going to have, this is x to the 1/3, so it'll be 1/3 natural log of x, that'll be that part, minus x natural log of e, just like that. Minus because it's a quotient inside, the argument is a quotient, and I'm pulling that exponent to the front of the log. Now natural log of e is 1, and you have to know that. Natural log of e is 1. So what we have here is just x times 1/3 natural log of x minus x. Okay? And I'm debating on whether to go ahead and distribute and then take the derivative, or just treat this like a product rule right now. And I think I'm just going to treat it like a product rule right now. So f prime of x is equal to, I start with the x and take the derivative. So this is a product rule where this is one term and this is the other term. So the derivative of x is 1, and we keep the other thing, leave it alone, plus for the product rule. Now I'm leaving the x alone and multiplying by the derivative of this piece. So the derivative of this piece would be 1/3 times 1 over x minus 1. So that is the derivative. I'm sure I have to clean it up a little bit for a multiple choice question, so I'm fully expecting to clean this guy up. So this is just 1/3 natural log x minus x, and this here, when we distribute this x through, the x's here will cancel, so that's just positive 1/3, and then x times the negative 1 is negative x. So we have 1/3 natural log x minus 2x plus 1/3. I'm hoping that's over there, but I'm thinking it's not. It looks like it might be something like this. So what would they have done here? They factored a 1/3 out. If you factor a 1/3 out, I'm going to have natural log x minus, what do we get when we factor 1/3 out of 2? Well, you're taking 2 and you're dividing it by 1/3. That is 6. So you're left with 6x. Try it again. Multiply 1/3 times 6x. Do you get 2x? Yes. So, and then this will be a plus 1. And sure enough, that's sitting right here. So the answer choice would be A. I need to get you used to manipulating your answer to suit one of the multiple choice answers. So whenever I can, in a worksheet especially, I will do that. Okay? All right, number 3. Find the slope of the line tangent. Well, here we are with the derivative again. To the graph of y equals this log at this point. Okay? All right, so we're finding the derivative at this point. And the first thing I see, yes, there's a log, but it's not a natural log. So the first thing I want to do is I want to change it to be a natural log. So I can change this using the change of base formula. This is natural log 4x divided by natural log 9. So I'm going to make that 1 over natural log 9. I'm just pulling it out, making it the coefficient. And then I have e to the x natural log 4x. And that looks much better to me than what we started with, because I like natural logs. This is just a constant, so this doesn't bother me at all. So when I'm finding the derivative, I'm just going to leave that 1 over natural log 9 out in front. And now I'm using the product rule, because I have 2 terms. So the derivative of e to the x is e to the x. Leave natural log 4x alone. Plus is part of the product rule. Now we're leaving e to the x alone and multiplying by the derivative of natural log 4x, which is 4x in the bottom, the derivative of 4x up on top. These 4's will cancel, and we have 1 over x here. So this is 1 over natural log 9 times, and at this point I think while I'm simplifying here, I'm going to go ahead and put 1/4 in for x. So to make my notation good for you guys, I'll say y prime at x is equal to 1/4. So I'm plugging in 1/4 for x. This is e to the 1/4. Natural log, if I put 1/4 in for x, 4 times 1/4 is 1. And natural log of 1 is 0. So that's going to zero out that whole piece. Plus e to the 1/4 times 1 over 1/4. So this is 1 over natural log 9. This piece is 0. Times, if I multiply here top and bottom by 4, this would be 4 over 1. So this is 4 e to the 1/4. Let's go see if we can find that. So I need ln of 9 in the bottom. This has ln of 9 at the bottom. There it is, right there. B again. Okay. All right, number 4. So in number 4, what is the instantaneous rate of change? That's another word for derivative of h with respect to x. So h prime of x we're trying to find. If h is this, okay? So h is this. It's not it's not an e to the x, it's a 2 to the x, so we're going to have to be careful with that. So I'm going to start by, I can just dive in. I was thinking I'd use the product rule, but this is just a 3, so I don't need to use the product rule here. I can just, that 3 is just going to hang out outside. And now I just need the derivative of 2 to the negative x squared. So here's my thought process. This behaves like e to the negative x squared, but it's a 2 to the negative x squared, so I need to multiply by ln of 2, and once I multiply by ln of 2, I can treat it like an e to the negative x squared. And the derivative of e to the negative x squared would be e to the negative x squared times the derivative of negative x squared. So this is 2 to the negative x squared times the derivative of negative x squared, which is negative 2x. So that's my thought process there. We can clean this up a bit. I can multiply the 3 times the negative 2x, so that would be a negative 6x times natural log 2 times 2 to the negative x squared. Let's go find that. I think it's A. Okay. Number 5. Find the derivative dy dx given y is equal to this function. It's a natural log, so I'm going to spread it out as much as I can first. So I'm going to have y is equal to, so it's a quotient, so natural log of e to the x minus natural log of e to the 2x plus 1. I can move this x to the front, and then I'll have natural log of e, which is just 1. So natural log of e to the x is x. Time for a derivative. Okay. The derivative of x is 1. The derivative of this natural log is a fraction. Whatever is the argument, I put that in the denominator. And then on top, I put the derivative of the denominator, because this is a chain rule. So the derivative of e to the 2x is 2e to the 2x. And then the derivative of 1 is 0. So this is the derivative. Let's go see if it's over here. I don't see it over here yet, so they must have gotten a common denominator and added these two terms. So the common denominator is e to the 2x plus 1. And then this is 1, so it's e to the 2x plus 1 over e to the 2x plus 1. So e to the 2x plus 1 for the 1 minus 2e to the 2x. And we can combine these two terms, and it'll be 1 minus e to the 2x over e to the 2x plus 1. And that is sitting right at b. Okay? So that's how I would do those first ones. Let's go on and take a look at number 6. So when I'm looking at number 6, it's a straightforward problem. Just find g prime. Here's g, find g prime. And I see that I need to use the quotient rule. Not quotient rule, product rule, because this is a product. So g prime would be the derivative of e to the negative x, which is negative e to the negative x. Keep your cosecant the same, plus, now I'm leaving e to the negative x alone, and I'm writing the derivative of cosecant of 2x, which is negative cosecant 2x, cotangent 2x, times the derivative of 2x. This is a chain rule, so derivative of 2x is just 2. So I'm looking over here and I see that they just have a single term, so they must have factored out something. So I see what's in common, and what is in common is this e to the negative x is in common. And I also see a negative sign in common, so I'm going to factor out a negative. And I also see a cosecant of 2x in common, so I'm going to factor out a cosecant of 2x. So I'm factoring out quite a bit. I'm factoring out a negative e to the negative x cosecant of 2x. From the first term, that's everything, so there's just a 1 left. From the second term, it's going to be positive because I factored out that negative. And I took this out, I took this out, so I'm left with 2 cotangent 2x. And let's see where that is. Okay, it's going to mean they're all negative, and they're all this e to the negative x. They all have the cosecant of 2x. 1 plus 2, it's d because of the 2. This one doesn't have a 2. So d. Okay, number 7. If this is our relation, then in terms of x and y, dy dx is what? So here's our equation, and we want to find dy dx. This is not going to be pleasant to solve for y. I would rather take the derivative implicitly, so that's what I'm going to do. So I'm writing down my equation, and we are going to take the derivative of both sides with respect to x. Why with respect to x? Because of this dx right here. That tells me what to take the derivative with respect to every time. So the derivative of 7 is just 0. The derivative of 3x squared is 6x. And with respect to x, that's just 6x. That's all it is. Over here, I see a little product. So I'm going to need to use the product rule, and every time I take the derivative of a y, I need to multiply by dy dx, because we're implicit differentiation with respect to x. So the derivative of 2x is 2. Leave your y squared alone. I have not taken the derivative of a y term, so I don't need a dy dx yet. Plus, now I'm leaving the 2x alone. The derivative of y squared is 2y. I just took the derivative of a y term, so I need to multiply by dy dx. I'm going to move my 2y squared to the right, and then divide by whatever was with my dy dx. And I see that everything has a 2 in it, so they probably, what did I do wrong here? Oh, I copied their problem down wrong. I'm seeing that there's nothing even close to it over here, so I knew I did something wrong. And I copied the problem down wrong. That was a 3, so I need to go and fix that. That's a 3, so this won't be a 6x, this will be a 9x squared. 9x squared, 9x squared. So now everything does not have a 2 in it. So hopefully this is sitting over here, and it is. It's A. Okay. Alrighty, number 8. Find dy dx if this is our equation. So again, we need implicit differentiation. So I'm taking the derivative of both sides with respect to x. Why with respect to x? Because I want dy dx. That tells you what to take the derivative with respect to. Need another product rule here, because I have a product of two terms. The derivative of x is 1. Keep your y. Don't need a dy dx yet because we did not multiply by, or we didn't take the derivative of a y. Plus, leaving the x alone, the derivative of y is 1, but we just took the derivative of a y, so we need dy dx. The derivative of tangent y is secant squared y. We just took the derivative of a y term, so we multiply by dy dx. I need to gather my dy dx's and then solve for it. So I think I'm gonna move this term over here. So I'll have y is equal to, while I move it over, I'm gonna factor out a dy dx. These are both gonna have a dy dx, so I'm factoring it out. We'll have secant squared y minus x when we move this term over. And then divide by whatever's with the dy dx, and we'll have y divided by secant squared y minus x. So we have to be careful finding that. Not negative. No, this isn't right because the signs are wrong. This looks like it, so B. Okay. Number 9. We've got another implicit differentiation. Find the slope, so we find the derivative. That means derivative, right? So finding the derivative. Here's our equation. Slope is always dy dx. So we're taking the derivative of both sides with respect to x. Okay, another product rule. Another product rule. Start with the x squared, take the derivative, 2x. Leave y. No dy dx. We haven't taken the derivative of y. Plus, leave the x squared alone. The derivative of y is 1 dy dx. Minus the derivative of 3y squared with respect to x would be negative 6y dy dx. And then the derivative of 5 is 0. Factor out a dy dx. Move anything without a dy dx to the other side, and then divide by whatever's with your dy dx. So dy dx would be negative 2xy over x squared minus 6y. Oh, I could have put my point in earlier. I forgot about my point. So I'm putting in 2 in for 2 in for x and 1 in for y. So dy dx at that point will be negative 2 times 1 divided by 2 squared minus 4 times 1, I'm sorry, 6 times 1. So this is negative 4 over negative 2. So negative 2, and clearly I did something wrong. What did I do wrong here? Oh, positive 2. There we go. Okay, so the answer is B. Okay, got the calculus right. Messed up on my signs. Alrighty, number 10. For number 10, here's our function. They are restricting our domain for us, and they say here's f, and g is the inverse of f. So this is going to be an inverse problem. Okay, we're finding g prime at 1/2. G prime at 1/2. So I like to do this on these problems. I like to start with my point on what I'm trying to find. So point on g is going to be the x-coordinate is going to be 1/2. I don't know the y-coordinate, but I do know that the point on f, since they're inverses, the corresponding point would have to have that 1/2 as its y-coordinate. And I can find this x-coordinate. I can find this x-coordinate because I know the function for f. So that's step 1, find that x-coordinate. So I'm setting cosine of 2x equal to the 1/2 to find x there. So if cosine of 2x is equal to 1/2, that means that argument, 2x, must be the angle that makes cosine 1/2, which is pi over 3. And when we're doing an inverse function, you guys, I know that I'm just going to take that very first one. It's going to get me right in this range, and I don't have to worry about anything else. Just take that first one in the first quadrant here. So x, if we multiply both sides by 1/2, x will be pi over 6. So now I know right here it's pi over 6. If I find this derivative, f prime, at pi over 6, well, f prime is the derivative of cosine of 2x, which is -2 sine of 2x. Okay, so f prime at its x-coordinate is -2 sine of pi over 3, which is -2 times square root of 3 over 2, which is negative square root of 3. Since f and g are inverses, I know that g inverse at its x value must be equal to the reciprocal of this, 1 over negative square root of 3. Always. Common mistake is to make it the opposite signs as well. But it's not the opposite signs, it's just the reciprocal. So this is going to be C. Number 11. Selected values of g and g prime are given in the table. What is the equation of the line tangent to the graph of y equals g inverse of x at the point where x is equal to -2? So we want to know the equation of the line tangent to g prime to g inverse of x, where the point is x equals -2. Okay, so in any time I'm writing the equation of a line tangent, I need a point and I need a slope. So the point on g inverse has x coordinate -2. X coordinate -2. Therefore, the point on G must have y coordinate -2, and I can use the table to go find that. So here's G, and G has a y coordinate of -2 when x is 5. So that's 5. So this must be 5. G prime at its x value, G prime at 5, is E. Therefore, the derivative of G inverse at its x value must be 1 over E, the flip of that. I have a point and I have a slope, so I can write the equation of the line tangent. Y minus the y value is equal to the slope times x minus the x value. let's see which one it is. Oh, it's C. Okay. All right, number 12. Oh, it's nice, a little related rates problem. We've got a 13-foot ladder leaning against a building. 13-foot ladder leaning against a building. The 13-foot ladder is never changing lengths, so I can go ahead and label it 13. Anything that's not changing, put the number in for it. If it is changing, give it a variable. The top of the ladder is sliding down the building. Here's my Y. That means this part of the ladder is sliding away from the building. So this is X. So the top of the ladder is sliding down the building at a rate of 5 feet per minute. So that tells me dy dt is equal to -5, because y is shrinking. I need to make that rate negative. -5 feet per minute. Okay. At what rate in radians per minute is the angle between the ladder and the ground? Here's that angle, the ladder and the ground. At what rate is that changing when the base is 7 feet from the building? So when x is 7. So I'm looking for d theta dt when x equals 7. Okay? All right, let's find out. That's what I'm looking for. So I need an equation that relates theta and y, and preferably only theta and y. I would rather not include x if I don't have to. So just theta and y. I know sine of theta is opposite over hypotenuse. If I use sine, I will get an equation that relates only theta and y. And that's what I would rather have. So now I have my equation. I need to look at the rates, so I'm taking the derivative of both sides with respect to t. Why with respect to t? Because that's what I need. Okay? The derivative of sine theta with respect to t is cosine theta d theta dt. The derivative of y over 13 is 1 over 13 dy dt. After you take the derivative, plug in your points. Plug in your values. So cosine of theta. So when x equals 7, now I can go in and plug in my numbers. Well, when x equals 7, I don't need to find y, because all I need for cosine theta is adjacent over hypotenuse. So cosine theta is 7 over 13. dy dt they gave us was -5. So I see this, both of these sides have a denominator of 13, so if we multiply both sides by 13, that 13 goes right away. Divide both sides by 7, and we get d theta dt is equal to -5 over 7. -5 over 7 radians per minute in this case. So that is answer choice B. Okay, number 13. So now we have a little FRQ. So if you have an FRQ, you need to be careful. You need to be careful and write every piece of your work down. I want you to write what you would have to write down if you were explaining it to somebody who didn't know what they were doing. That's a good rule of thumb to use in an FRQ. On the test, I was pretty lenient, and this time I'm not going to be lenient on my FRQs. I need you to get used to writing what needs to be written really quickly, so that you can spend the entire year using good, showing good work along the way. By the time May 4th comes along, you're going to be in good shape. Okay, so consider this curve. Show that dy dx is equal to this. Yes, AP will do this. So show that dy dx is equal to this. Well, we need to show that. So in essence, we need to take this and find dy dx. So here is my equation. I am taking the derivative of both sides with respect to x because I'm needing to find dy dx. The derivative of y cubed with respect to x is 3y squared dy dx. For this next piece, I'm going to need to use the product rule. So the derivative of negative x is negative 1. Leave y alone. Now we're leaving the negative x alone, and the derivative of y is 1 dy dx. Over here, the derivative of 2 is 0. Okay? Group your dy dx's together. Move anything without a dy dx to the other side. While I'm doing it, I'm going to factor out a dy dx. And lastly, divide by whatever's with your dy dx. Okay? At this point, I'm looking at, did I do what I was trying to do? Did I do what I was trying to do? Yes. I did it exactly. If this didn't exactly match, I would go ahead and write it exactly matching. If they say show that this is true, you want to show that that is true. So we showed it, so we are done with that piece, QED. Okay? So before I go on to part B though, I want to, why do you think that they would pose it like this? Why wouldn't they just say find dy dx? The reason why they didn't say that, the reason why they gave this to you was because we're going to need that in another part of the problem. And they didn't want you using the wrong dy dx throughout the whole rest of the problem. Okay? That's why they do that. But you're going to treat this like it says find dy dx. You treat it like that. They're just giving you the answer. Okay? So since they gave you the answer, how many points do you think that answer is going to be worth? Nothing. That's all the process. That's all that's going to count is your process. Okay? So keep that in mind. Keep that in mind. All right. Write an equation for the line tangent to the curve at the point -1, 1. Well, any equational line, we need a point and we need a slope. They gave us the point and they gave us the slope because they gave us the slope right here, right? So for the slope, dy dx at that point is going to be, I'm putting 1 in for y, and I'm putting -1 in for x, right? So that's the slope. If you want to clean it up, clean it up. Otherwise, just leave it like that. I am going to clean this up because I'm about to use it, so I'm just going to clean it up. And I'm pretty confident that I can clean it up. So the slope is 1/4, okay? But again, if you were less confident, if this was a messier problem, then you just leave it right like that, okay? In fact, what you could do here is, since we now have it named, you could just use this name in your equation of the line, okay? And even if you thought that this name was too messy, you could name it something else. I could name this A or B or something. So you can name it and then use the name in your equation. So I'm going to write my equation like this. Y minus the y value is equal to the slope times x minus the x value. And that's it. I stop there. That is an equation. You don't have to solve for y. That's an equation. All right? Okay, next up, find the coordinates of all the points on the curve at which the line tangent to the curve at that point is vertical. I want it to be vertical. Okay, well, if the line tangent is vertical, that means the slope is undefined. What I just said in words, you need to write down. Okay? You never know what's going to be worth a point on the AP exam, so you write it down. So the tangent line is vertical when the slope, dy dx, is undefined. Say that. Okay? It may be worth a point, maybe not, but maybe it is. You don't know. Okay, so dy dx is equal to y divided by 3y squared minus x. And this is undefined when what is happening? How do you know when a fraction is undefined? Well, the denominator is going to be 0. So this is undefined when 3y squared minus x equals 0, right? So this gives me that 3y squared is equal to x. I need to find the points that make this true, right? Need to find that when this is true. So I'm looking around. I want to know how to solve this. So I'm looking at my problem. I know that's going to be true, but I also know that this is true, right? I know that that is true, and I want this to be true. So since I'm pulling out my equation, since y cubed minus xy is equal to 2, that gives me that I'm going to put 3y squared in for x right here. I wouldn't show that little arrow on AP exam. I'm showing that for you guys, okay? But I'm putting that right there. So then I have y cubed minus 3y squared times y must be 2. Well, these are like terms, aren't they? Y cubed minus 3y cubed is negative 2y cubed. So y cubed is negative 1. Therefore, y must be negative 1. And now I just need to find x there because we want the points. So I'm going back into this equation and I'm putting negative 1 in for y. So negative 1 cubed minus x times negative 1 is equal to 2. This is negative 1 plus x is equal to 2. X is equal to 3. So the point would be 3, negative 1. That's how I would do that problem. Okay. Part D. Let's see. Evaluate the second derivative at the point on the curve where x is negative 1 and y is 1. The second derivative. They do like to do this. If you find the first derivative, then you'll find the second derivative. You might even be asked a question about that second derivative. So I'm taking the derivative of the first derivative. So there's my first derivative. I have it written right here. So there's my first derivative. I'm going to take the derivative with respect to x. So since I'm taking the derivative with respect to x, every time I differentiate a y, I need to multiply by dy dx. This is a quotient rule, so I need to use, or this is a quotient, so I need to use the quotient rule. So it's going to be a fraction. On the bottom is going to be 3y squared minus x all squared. Okay, on top. I start up on top and take the derivative. The derivative of y with respect to x is 1 dy dx. Leave the bottom alone. Minus is part of the quotient rule. Now the derivative of the bottom is 6y dy dx minus 1 times the top, part of the quotient rule. So there's the derivative, and I know I've looked at enough of these AP exams to know that that's always worth a point. Okay, using the implicit differentiation and the quotient rule. It may be worth 2 points, but it's at least worth 1. Okay, now we are going to plug in x equals -1, y equals 1, because they told us to. Okay? All right. X equals -1, y equals 1. I need dy dx at that point. Well, guess what we found up here? We found dy dx right there. It was a fourth. So that's a fourth. This is a fourth here. Okay, y is just 1, so we have 3 minus a -1 here. And then 6 times 1 times dy dx, which is a fourth, minus 1 times 1, all over 3 times 1 minus a -1 squared. Safe stop. Don't go any further. Leave it just like that. Why would you risk it? Just stop. It's all numbers. Stop. Okay. Oh goodness. Okay. Number 14. Given f of 3 is 7 and f prime of 3 is a half, and now we have the function h, and that is defined by h of x as natural log of f of x. Find h prime of 3 and show the computations that lead to your answer. Okay. Well, if this is f of h of x, I just need to find the derivative. I can do that. So h prime of x will be, it's a natural log. So the derivative will be a fraction. In the bottom of the fraction will be the argument, whatever the argument is. In this case, it's f of x. On the top of the fraction, it'll be the derivative of the argument. Well, the derivative of f is f prime. So now we're plugging in 3 for x. So we're going to have f prime of 3 divided by f of 3. That is not a safe stop spot. You cannot put this in your calculator. Don't stay. This is not all numbers. That was all numbers. This is not. I had somebody on the test stop when it was still f's, and you can't do that. F prime of 3 is a half. F of 3 is 7. That's a safe stop spot. So we'll safe stop it. Okay. A few more little ones to do. Let's see. F and G are inverses. And the point AB is on the graph of F. Okay. What point must be on the graph of G? Oh. BA. Has to be. That was easy enough. If the slope of F at x equals A is M, then what is the slope of G at x equals B? Well, those are corresponding points. We just showed that. So the slope of G at x equals B would be 1 over the slope of F there. 1 over M. Well, that wasn't too bad. I could do that all day long. 16. Another inverse one. Okay. This time they give us h. Find h prime, h inverse prime, so the derivative of h inverse at 2. And then write the equation of the line tangent at x equals 2. Okay, so h prime at 2. So I'm thinking point on what I'm trying to find, h inverse. Well, that one has a 2 as its x coordinate. Don't know why. So a point on H must have a y coordinate of 2, and I can find x. I can find x by setting y equals to 2 in that function. So x cubed minus 2x plus 3 is equal to 2. And I'm sitting here thinking maybe I can factor this. How can we do this? That doesn't factor. So here's my thought. Let's see. Here's my thought. I'm just going to kind of guess and check. I know there's only one value because these are functions. So I'm going to guess and check. I'm going to try x equals, I know x equals 0 won't work because 1 doesn't equal 0. So I'm going to try x equals 1. And if that doesn't work, I'll try x equals -1. And I'll keep going from there. So when x is 1, I'll have 1 minus 2 plus 1 is 0, and I've already found it. So x must equal 1 there. I don't like having to guess and check, but these, I know it from working enough of these AP problems, they're usually easy enough. You don't have to go through all of the work that you went through in pre-cal to find that 0. Okay? Just guess and check. All right. Now we need h prime at its x value. So first we find h prime of x. H prime of x is 3x squared minus 2. So h prime at its x value is 3 minus 2, so it's 1. That means that the derivative of h inverse at its x value is 1, because the reciprocal of 1 is 1. That's nice. We also know, so we've done that part. That's fine. And now we know the point on h inverse has to be 2, 1, since the point on h is 1, 2. So the equation of the tangent line would be y minus the y value is equal to the slope times x minus the x value. And we're done. Number 17. A particle moves along the portion of the curve r is equal to 3 plus 2 cosine theta, throwing a little bit of a polar equation at you. We'll see what you remember for this portion of the curve. Okay? The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. All of a sudden now I'm seeing a related rates problem. I see here's this rate of 3 units per second. Well, what is it? If it's a rate, it's d something dt. So d something dt is equal to positive 3 because it's increasing. Positive 3 units per second. Okay, well, distance. The distance from the origin is going to be r. I know it's going to be r because cosine of theta is always between -1 and 1. So this will always be positive. So the distance will be always, r will be always positive here. So that means r is that distance. So this is dr dt. So they're giving me dr dt is 3. Find the rate at which theta changes when theta is pi over 3. Okay, so we're trying to find d theta dt when theta equals pi over 3. They gave me an equation. They gave me these. This is one of the easy kinds of related rates problems where they already give you the equation and you don't have to do a thing to it except take the derivative and plug in your numbers. So we are taking the derivative of both sides with respect to t, just like we do in every related rates problem. So dr dt is equal to 0 minus 2 sine theta d theta dt. Time to plug in our numbers. dr dt is 3. Let me say what I'm doing. When theta equals pi over 3. When theta equals pi over 3, dr dt is 3. -2 sine of pi over 3. A safe stop spot would be sine of pi over 3. Just leave it like that. If it's an FRQ, you can do that. Times d theta dt, which is what we're trying to find. So d theta dt will be 3 divided by -2 sine of pi over 3. All numbers except for a sign, which is fine. That's fine to say stop. All numbers except for a trig function, yeah, you're good. You can say stop there. We do have to indicate units of measure though. So indicating units of measure, let's see. d theta dt, what would units for theta be? Units for theta is always radians in calculus. Radians per, what are my units for time here? Seconds. Radians per second, and that's it. If that bothers you to leave it sine of pi over 3, go ahead and put something else in. That's okay. But if you do, I'm going to say stop here, and then I'm going to say that's negative sine of pi over 3 is square root of 3 over 2. So the 2's will cancel out. We got negative 3 over square root of 3. You could even rationalize that if you wanted to. So you can do all of that if you want to, or you can say stop. Up to you. Okay? All right, one more. A cylindrical tank. I love me a cylinder. Why do I like a cylinder? Because the radius never changes. I get to put in a number for radius. Okay? So in this cylinder, and I know they're going to tell me what it is. They may not say it directly, but they're going to tell me what that radius is. They always do. Okay? A cylindrical tank is being filled with water, so the volume is growing, being filled with water at a constant rate of 4 cubic meters per hour. I see cubic meters, and I think that's volume per hour. That means they're giving me dV dt. So they're giving me dV dt is equal to positive 4. Positive because the volume is growing. Okay? The tank has a circumference of 20 meters. They just gave me the radius. Why did they give me the radius if they're giving me the circumference? Because circumference is directly related to radius. So circumference is 2 pi r. The circumference is 20. So they've just told me that r is equal to 10 over pi. And that is not changing in this whole problem. The radius is equal to 10 over pi. Okay? Alright, and the tank has a height of 40 meters. Alright, the volume of a cylinder is given by this. Okay, what is the volume of the water when the water is 25 meters? When the water is, okay, that's a little typo. That should probably say the height of the water. Height of the water is 25 meters. Okay? I hate noticing a change after I just copied all of these worksheets for you guys. But, oh well, that happens. Okay, so what is the volume? Are they asking me for the rate of the volume or just the volume? You need to be really careful and read the problems. If they're asking you for a straightforward answer, don't take a derivative. Just find what they're asking you to find. What is the volume when the height is 25? Well, here's my equation for volume. R is always 10 over pi, so in my problem, this is the equation for volume throughout my entire problem. Okay? If they want the water level to be 25 meters, I can do that. So V when H is 25 is equal to pi times 10 over pi squared times 25, and that is a safe stop spot. So I'm stopping. Okay? Why would I not want to stop? Okay, I do have to indicate units of measure. So what would units for volume? This is not a rate, just volume. What are units for volume here? Well, they kind of gave it to me right here, cubic meters. Or you can actually write out cubic meters like they did. That's fine too. Okay? Part B. At what rate is the height changing? Now we're looking for a rate. At what rate is the height changing? So we're looking for dH dt when the water is 25 meters deep. Okay? So now I'm going to go back to my volume equation, but I'm using this volume equation. Okay, we can clean it up a little bit. I probably would clean this up a little bit, but this is just a number, so you don't have to clean it up. You could just leave it like that. But if you want to make it 100 over pi, that's fine. Okay? So at this point, since we're looking for a rate, take the derivative of both sides with respect to t because of that dt. So dv dt will equal, this is all just a number and it's in front of h. So the derivative of that is just that number times 1 dH dt. Implicit differentiation there. After you take the derivative, plug in your values. So we would plug in 25 for h. We would plug in 25 for h, but there's no h to plug that in for. And I'm plugging in 4 for dv dt. Oops. And now we're solving this for dH dt. Okay, this is getting a little bit silly to not simplify this guy. But this would be 4 times pi squared, because this is a pi squared, so I'm multiplying that pi squared over, divided by 100 pi. And you can say stop there. Okay, if you don't want to say stop there, that would be pi over 25. Okay? Did they ask for me for units here? They did not. They asked for units in part A, so I gave it to them. If they didn't ask for me for units here, I'm not going to give it to them. Okay? All right. So, hopefully this helped you out a little bit for the test. And anyway, if you have questions, come to tutoring. All right.